So we're back. For example 1 here, draw a line of best fit. Now this is quite easy to do, I think. Once you've got yourself your coordinates, how do you draw a line of best fit? You have to use a ruler, and I'm just using a ruler on this trackpad. And you have to go really from the beginning all the way to the end. So my ruler's not actually long enough here, and it's a bit difficult to do on this trackpad. But it should go about here. I'm going to try that. Yeah, not bad, not bad. So that's going to be my line of best fit. You do it with a ruler, and it's got to have it's got to be between the highest points and the lowest points. And people are generally pretty good at doing this by eye. Lines of best fit. It looks to me as though actually I may have done this a little too high, because these points here are quite a lot below, and the ones above aren't really that much higher. So yeah, maybe it should be a little lower. But it says here, use the line to predict the value of y when x equals 12. So when x is 12, that's here, and then we would draw a straight line with a ruler again up to here, and then draw a line across. That has to be done with the ruler to give this point. So using my line of best fit, it should be about 6.8 or 6.7 maybe. So you'd say that y equals 6.7. But using probably a better line of best fit, the answer is probably likely to be around 6.5 or 6.4. Right, let's have a look at example 2. My video's gone a little bit skew there. Right, so the following data was collected from an experiment. In the experiment, objects of different masses were placed on a horizontal surface, and then the force needed to make them start to move was recorded. So we're going to have a stone on a table, and then how much force do you need to put on this to make it start to actually move? So this is our table of values. We've got different masses here with different forces you would need. And it looks like the larger the mass, the larger the force. And it's asking us to draw a scatter graph to estimate the force needed for 2.5. So 2.5 is in the middle. Now, if you're trying to find a point, you're trying to guess a point that's in the middle of the data, it's called interpolation. And that is often much more reliable than what's called, let's say if this said 25 kilograms, that's all the way over here, and that's outside the data. That would be called extrapolation. Extra means outside, so extrapolation. Extraterrestrial, outside the Earth. So this interpolation is generally much more reliable than extrapolation. So this is likely to be accurate, whatever we do here. So if we actually drew that, we would end up with this here. And by drawing a line up from 2.5 and then across, we can see that it will require a force of 10 newtons. So yeah, that's it really. It's interpolation, looks pretty accurate. Looks like all these dots are pretty close to the line of best fit. So it looks like it's a fairly strong correlation as well.